is printing some nice stuff to the terminal. This one is a bit complicated because the terminal is not really made for playing games, I guess. The way to interact with the terminal is through ANSI keys. There's this nice repository describing the ANSI escape code you can use. And what it boils down to is you have an escape key you can send to the terminal, and if you send that, then you can send all these special characters which do stuff with the terminal. This way you can change the way it looks, but also get some input back. So first we need to get the escape key, and we can get that through typing add plus 27. This will do some character arithmetic, and the 27th character after add, I guess, is the escape key. So I don't know more, but that's how you get the escape key. There are some cool things we can print out now, which will do stuff with the terminal. For example, this code you can do bracket 2j, and if you send this to the terminal, it'll clear the screen. I don't know, it's acting a bit weird, but it's supposed to clear the screen. We can save that here. And another cool thing is bracket h, which means home. So it'll move the cursor to the top left corner. You can save that as well. Yeah, so you can combine these two, and without an escape key they aren't very useful. So we can do this, escape composed with these two, which is just gonna add the escape key to the left of them. And if you now print these, or I guess I need to use out, they're gonna do their behavior. Let's make one combined string, which is just gonna be reset. That'll clear and home the cursor. That's just clear screen combined with home. There we have the reset. Let's also make some nice functions for printing. So p for print. For now it can just be out. Assuming if we call p with hi, for example, then we get hi back. But the problem is if you give it the field, for example, which is a 2x2 array, it'll give us an error because it doesn't want to print that. You can print these 2x2 or higher dimensional things with show, which is very nice. This is very useful. The problem is if you print a string, the string field, then you also get these quotes, and we don't want that. So what I did, it's a bit of an ugly way, but is to check the rank of x is smaller than, or if 1 is smaller than the rank of x, which means if it's bigger than 2, then do show, otherwise do out with x. So it'll use out for lower dimensional things and show for higher dimensional things. So now field is without quotes. I mean, the string is without quotes, and field would be, you can actually see it. So it's also nice to have a delay to have the interaction loop. That's just the same as delay. It's just a shorthand now. And it's nice to have this reset, where we just show or out this reset string. This needs to be a function. Yeah, so we have these functions now. And we can, for example, just do r, call it with the parameter, and then you just clear the screen. Another big thing we want is to get some input, because as you could see in the last example, we were able to move the cursor with our arrow keys. I like that interaction, but we need to get some input to be able to move this cursor. We can get input from term.charb. You can see in the specification of BQN there of the system provided functions, there is some terminal input-output stuff, and in terminal IO there is this charb, which is reading a character and blocking, which is useful for us. What's also useful is this raw mode, because normally the terminal has some behavior for dealing with the input. And you can see that if you run a while loop, which doesn't stop, and you run the program. If you run the program, then you can see if I type, I get all these weird characters, and if I press enter, it'll be send. we don't want this behavior. Normally it's handy if you just type stuff and then you press enter, it will send it to the terminal and they can do stuff with it. But we want stuff to run immediately to the backend. And you can do that with this term.raw mode 1. Then make sure you don't see all the characters you're typing, and it'll send it immediately to the backend so we can read it. So we want this enabled, and we want to use the term.charb. If you run this and just print what it does, it'll first block the whole program before you give any input, and then if you give an input, it'll print that out now and end the program because there's nothing to run anymore. What we want to do is to match on something that charb is collecting. So we can put this in a while loop, like so. And store the value of what the terminal is getting to X. Or actually we want to attach it to the terminal, to the X value. So each time it's getting a new character, it's gonna add it to the thing going through the while loop, which means we're here getting the string, which is collected. I'll just show it. Or out. If I run this, okay, so this is now the string, and if I start typing, then each time it's going to add what I type to it, and then print it out. You get a nice messy list, but this is not what we want, of course. First, I'm going to separate this with get char or collect char, I guess. This is just a function which gets an element and attaches a new character to it. This we pass into the while, which is a bit nicer, and we'll wrap this whole thing in a function in get char, because we want to standardize this a bit. What we want to do is match on a specific arrow key which is pressed. Okay, if I remove this outer function for a second and turn off raw mode and start typing stuff, you can see what I get back. So the right arrow is going to give me a caret bracket bracket C, and the left caret bracket bracket D. What I did last time is just to use the brackets capital B or capital A, capital D. Because they work. I just match on those and I get the input. So let's define those as right, down, left, up. So these are the characters which we're getting from the terminal which we want to match on. Let's turn raw mode on again and enable the function. So essentially what we want to give to this function is these keys we would like to match on as a parameter. And then this will give us back which key is being pressed. So let's write a function called find, which will find in this string which is returned which key is being matched. Finding something in a string is, you can use this function for find. And if you were to now give this a string, hello, and match that on hey, for example, that will give us this thing, which is the top leftmost position. So H and E is matched as 1, 1, and then the other three are not matched. So that's 0, 0, 0. And if this will be LO, and we run this, it will match on. It doesn't match the first three, but it does match the last one. And just to make it even more clear, if I do 2 L's, it'll match there already. That's what we want to match, but we have an array of stuff, so we want to match on multiple things, so we can go over those with each. If I were to do the same thing now, find the blah 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 in one of the keys, I'll say this in here. Now we're going over the different keys and going over this string. Let's turn this off so we can grab this. This will give this error, equal shape prefix problem thingy, because it will also try to map over the right argument, this one. We don't want to map over that one. What we can do is enclose it, which means we're going to wrap this, like you'd see here, in an array, and if you map over this single array on the right, then it's just going to pick the first element each time because there is only one element, which is a neat little hack to do these each over one constant value and one dynamic or one array. So this gives us back, oh yeah, I need to stop doing that. This gives us back this array where you can see this one isn't matched, this one isn't matched, this one has a match. That's the D on the first thing, and then the rest isn't matched, and this one isn't matched either. So we get back this whole array if there is a position in this string where one of these characters is found. All we need to do then is to see if there is one value true, so an OR, and we do that as a fold over each element. So we are folding each element of this array. And this will give us back an array where we have the same index as this one with a 1. So the one that's matching, we get a 1 back from, because we're folding up these arrays, and this one has a 1 in it. So that one stays 1 in it, the ones are 0, if that makes sense. And that's exactly what we want. This we want to use here to see if our input is matched. Let's enable this again. So the right function to a while loop just returns 1 if it should continue running and a 0 if it should stop running. We're gonna see if one of the keys are in the currently collected value. And we want to escape this whole thing if one of these is 1, so an OR fold. But actually now we're getting back a 1 when there is a match, and 1 means continue on. We want to do the opposite of that. We want to stop when there is a match. So I do the not, which is the opposite. This will give us, if we run this, get char with the keys. I'll run it here. This needs to have an S, so it's a function. Yeah, it'll now just return the string that is collected, but we don't want that string that is collected, we want this index. And there should be a better way to do it. I'm just not smart enough. But what I do now is just do the same function, find, again, on this string that is returned, which is just the string that's collected, because this returns the X value after finishing. And find on the keys again. So this is the same function as before, where we get the matching keys. So now we get back, oh yeah, let's show this. We get back this matching index, which is perfect. So that's how we're getting some input from the terminal. So now we can output some stuff, get some input, that's perfect. Let's go on to the